Dear students, now we are going to discuss parallel binary adder and its applications in detail. Before going to discuss parallel binary adder, we should know why do we go for this parallel adder. In the last lecture video, we discussed full adder circuit. There are some limitations with this full adder. Full adder is mainly used to add 3 bits, maximum of 3 bits. But in real-time applications like modern computers and calculators use number systems ranging from 8 bits to 64 bits, even more than that. Okay. So in order to perform multi-bit addition, we need to have several full adders connected in parallel. Okay. So we need to have several, more than one full adders connected together. Okay. So here parallel binary adder performs the multi-bit addition. So n-bit addition can be done by using parallel binary adder. Here in this parallel binary adder, all the bits are fed into the adder circuit simultaneously and the additions of each bits are taking place at the same time. So we can perform the addition of each bits at the same time. That's why it is called as parallel binary adder. N-bit binary adder can be constructed using n number of full adder circuit. So here the rightmost full adder represents the least significant bit of the sum output of the parallel adder. Here the leftmost full adder represents the most significant bit of the sum output. Here this carry out represents the final output carry of the parallel adder. Okay. So here in this n-bit parallel binary adder, we are going to give all the bits of the input binary numbers to this adder circuit simultaneously. Okay. So here full adder needs 3 inputs. 2 from binary numbers, input binary numbers, and 1 as a carry input. Okay. For this first full adder, we have to give this input carry as 0. That's why we have grounded it. Okay. So input carry is 0 here. Okay. The output of the carry output of this first full adder can be used as the input to the second full adder. The output carry of this second full adder is given as the input to this third stage. So this is how we can give the carry input to each stage. Okay. In parallel binary adder, carry output of each adder is connected to the carry input of the next higher order full adder. So here as we know that the carry output of each stage is given as input to the next stage. So hence it is called as ripple carry adder. So here parallel binary adder is also called as ripple carry adder. Consider 4-bit parallel binary adder. So here we are using 4 full adder circuits. Correct? So here A0, B0, A1, B1, A2, B2, A3, B3. In the initial stage, the carry input is equal to 0. Okay. There are 4 bits in the sum output S3, S2, S1, S0. And the final carry output is C out. Let's consider this example. We are going to add 2 4-bit binary numbers A and B. So here A is 1001. B is 1010. We are going to add these two numbers together using parallel adder method. So in this parallel adder, the C0, that is the carry input at the very first stage, is 0. So 0 plus 1 plus 0. Correct? Since we are talking about full adder, we have to add these 3 bits. Okay? So 0 plus 1 plus 0 is 1. There is no carry generated. So if there is no carry means for this next stage, the carry input is 0. So now 0 plus 0 plus 1 is again 1. There is no carry. So we can say C2 is 0. 0 plus 0 plus 0, again 0. And C3 is also 0. So 0 plus 1 plus 1. 1 plus 1 means it is 1 0. Correct. 1 plus 1 is equal to 1 0. So take the 0 as sum and move the 1 to carry output. So here finally we can obtain the sum value as 0011 and the output carry as 1. Nowadays, the logic circuits are available as integrated circuits. So here IC 7483 represents the 4-bit binary parallel adder. So here we are having two 4-bit binary numbers, that is A and B. Both are given as input to this IC 7483. C in, that is the input carry. Initially its value is 0. Here C out represents the final carry output of this 4-bit adder. S3, S2, S1, S0 are the 4-bit sum value. In order to perform the addition of large binary numbers, we can cascade several parallel adders together. Okay, so here we can cascade two 4-bit parallel adder to perform 8-bit addition. Okay, 7483 represents 4-bit binary adder. So we can cascade this to 4-bit binary adder together to perform 8-bit addition. So likewise, if we are going to cascade 4-bit parallel adder means we can perform 16-bit addition. Is that okay? So multiple parallel adders can be connected in series to perform the addition on large binary numbers. Okay? Parallel binary adder is widely used in modern computers and calculators, especially for multi-bit addition. Limitations of parallel adder. In a parallel adder, the carry output of each full adder is connected to the carry input of the next higher adder. So as we know that the carry output of each stage is given as input to the next stage. Hence, the higher order adder cannot perform its operation without the carry from the previous stage. This leads to a time delay in the overall addition process and its speed of operation is limited by the carry propagation delay. Here the propagation delay is the time difference between the applied inputs and the generated outputs. Okay, the time taken for generating the output, that is what the propagation delay. So here in this 4-bit parallel adder, we can consider or assume that each full adder has 20 nanoseconds delay. So each full adder has 20 nanoseconds delay means the total time required for the final output, because there are 4 adders. Okay, so first the second full adder has to wait for getting its carry input from the first stage, right? So for that the second full adder has to wait for 20 nanoseconds. Okay, so then the third stage full adder has to wait for 40 nanoseconds to get its own carry input from the previous stage. So finally, the fourth stage, the final stage, has to wait for 60 nanoseconds to get its carry input. So on the whole, we can say the total time required for the final output is 80 nanoseconds. This 80 nanoseconds for this 4-bit binary adder is okay, it's tolerable. But in case of 16-bit additions, okay, 16-bit addition means this propagation delay extend to 320 nanoseconds. So in order to speed up the adder circuit or the adder operation, addition operation, so fast adders are used. One best example for this fast adder is carry look ahead adder.